Hi, Assalamualaikum. My name is Muhammad Firdaus.
My name is Muhammad FIKRI bin Muhammad Rafi. My ID number is TE21022.
My name is NADIERA binti RIHASFULDEEN. My street number TE21020.
Hi, my name is QISTINA binti HUSSEIN. My student ID is TE21029. And I'm going to explain about introduction of Hooke's law. Hooke's law is a law of elasticity discovered in 1660 by the 17th century British physicist Robert Hooke. Hooke's law is only a first-order linear approximation to the real response of springs and other elastic bodies to applied forces. It must eventually fail once the forces exceed some limit, since no material can be compressed beyond a certain minimum size or stretched beyond a maximum size without some permanent deformation or change of state. Many materials will noticeably deviate from Hooke's law well before those elastic limits are reached.
So I'll proceed with theory of Hooke's law. An ideal spring is remarkable in the sense that its system generate force is linearly dependent on how far it is stretched. Hooke's law stated above that to extend a spring by an amount dx from its previous position, one needs a force F which is determined by F equal to K dx. K is the spring constant, which is a quality of each spring. Hooke's law must verify that the force F and the distance at which spring is stretched are proportionally to each other.
Objective of Hooke's law. The main objective of this experiment is to show Hooke's law of spring, calculate the total energy absorbing in the spring.
These apparatus that we use in this experiment, Hooke's law. The first is sand for the mass, then plastic container, scale, digital scale, measuring tape, and the most important is rubber band. This is how I set up apparatus for the experiment. I place the measuring tape vertically, hanging a rubber band on the pen. The bottom of the rubber band must be at 0 cm. Since the mass of the plastic container is already 10 grams, I add another 10 grams to get a 20 gram mass. Then, hang a plastic container on the rubber band to get the stretch of the rubber band. The stress measurement of the rubber band will be recorded and entered into the datasheet. Repeat the steps for 12 trials, and the last mass is 200 grams. This is the last trial. Its mass is 200 grams. Then, as before, the data will be recorded and included in the data sheet.
Here's the result. And for the safety precaution, keep a distance from the apparatus. Be sure that the spring is tightly attached to the clamp, and as well as do not play around with the meshes or springs. Thank you.
The discussion is everyone knows when applying force on a spring or a rubber band, it will become stretchable. Hooke's law has stated that the strain on a material is proportional to the stress exerted within the limits of elasticity on the material. When an elastic material is tension, the atoms and molecules of the material change shape until a strain is applied, and when the strain is released, the material
And
returns
for the
to its
conclusion,
original shape.
Hooke's law says that the stretch of a spring is directly proportional to the applied force. Engineers say stress is proportional to strain. In symbols, F equal Kx, where F is the force, X is the stretch, and K is a constant of proportionality. If Hooke's law is correct, then the graph of force versus stretch will be a straight line.
That's all. Thank you.